Good day. My name is Rianmar Lacia, and today I will be covering the topic of kinematic diagrams. I will be showcasing to you the kinematic diagrams of four different mechanisms while giving an in-depth explanation as to how I obtain these answers. Before we start solving these problems, it is critical that we are aware of what kinematics really is and why is it so important. Kinematics is the branch of mechanics that prioritizes the motion of objects without reference to any of the forces that causes the motion. It is a schematic line diagram that shows the arrangement of links and interconnections and reveals the kinematic chains. Kinematic diagrams are important because it allows the person to have an easier time analyzing the motion of a machine and visualizing the movement of the components in a full assembly machine drawing or figure. The first example we have is a rock crushing machine. The first step in constructing a kinematic diagram is to determine the location of the frame of the mechanism. Deciding what part will be the frame will make it easier to determine the motion of all the other links. In this mechanism, the frame of the object is located here. And we'll call it link 1. It possesses a revolute movement. Link 2 is a simple binary link that possesses two pin joints and acts as a crank that triggers link 3 to move. Link 3 is a simple binary link that possesses two joints that connect it to link 2 and 4. Link 4 is a binary link that possesses the point of interest and is represented by a triangle, which signifies that it is a point that has no identifiable connection. The mechanism contains three revolute pairs. These are lower pairs, links that can rotate relative to another link. The frame, which is represented by link 1, the crank, which is represented by link 2, and the simple binary link 3. The rock crushing machine operates by movement generated from the frame of the object, which affects the link 2 or the crank. And because link 2 is connected to link 3 by a joint, it also causes it to move. Since link 3 and link 4 are also connected by a joint, the motion that originated from link 1 is delivered to link 4, wherein it applies the force and crushes the rocks. The next example that we have is a toggle mechanism. Let's start by locating the frame of the mechanism so that we'll have an easier time determining the motion of all the other links. Link 1 is the frame, which is the base that is bolted at the table during machining operations. Most frames are firmly attached to the ground. Link 2 is a link that possesses a point of interest at the handle and is represented by a triangle. Link 3 is a link that also possesses a point of interest and is also represented by a triangle. Wherein the point of interest is located at the nose of the clamp vise. Link 4 is attached to the base of the table. And aids in keeping the toggle clamp in place while operating. The point of interests are labeled as X sub 1 and X sub 2. The next example that we have is a shear press. The frame of this mechanism is attached to the ground and is located here. And will be labeled as link 1. Link 2 is a revolute pair that is considered as a handle. Which is connected to link 3. It is represented by a triangle wherein the point of interest is located at the end of the handle. Link 3 is the cutting blade of the shear press and is a binary link that connects link 2 with link 4. Link 4 is a prismatic pair that connects the cutter with link 2. Pin joints are used in order to connect the links with one another, which can be located here, here, and here. Furthermore, a sliding joint is also included and is used in order to connect link 4 with the frame of the mechanism. The last example is a power hacksaw. The frame of the mechanism, which is located here, will be labeled as link 1. Link 2 is a binary pair that connects the frame of the mechanism with link 3 via a pin joint. Link 3 is a binary pair that connects link 2 with link 4 through the use of pin joints. Link 4 is the prismatic pair in the mechanism and possesses the saw in the power hacksaw. Since power hacksaws require reciprocating linear sliding motions, a slider crank mechanism is implemented and used in this device.